This is chapter 11 test for 2020-21. So question number 1, they want an expression for the area of S. So you don't have to actually calculate the area, just the expression for it. So the general form for area is 1/2 the integral from a starting point to an ending point of your radius d theta. Well, you need the starting angle and the ending angle that produces S here. So a couple things going on. How do you get -2? So you need to calculate this. We have r equals 4 sine 2 theta minus 2. Now, since you're allowed to use your calculator, you could just graph this on a regular normal function mode and try to figure out what's going on here. So you may think r here is -2. It's actually either +2 or -2, depending on what your angle is. So if your angle is 0, then r would have to be -2 to get here. But if your angle is pi, your r would have to be 2 to get here. So you could either set this equal to 2 or -2, or just find your r at 0 and r at pi and see which one matches up. So I could say, hey, what's r at 0? That's going to be 4 sine 0 minus 2, which is -2, which makes this point here the correct point. So it's going to be 0. So that's my starting angle. That's an angle of 0. So what's weird, let me map this out with this color. So at 0, I go -2, which puts me back this way. But as I sweep through angles, I'm going to get to this point here. What's significant about that point? That point, your r is 0. So that's your next thing to do. You want to set r equal to 0. So you do 4 sine 2 theta minus 2 equals 0. Add 2 to both sides. Divide both sides by 4. And you inverse sine both sides. So when you inverse sine the left side, you're left with 2 theta. Inverse sine of 1/2. What angle has a sine of 1/2? That's pi over 6. Divide both sides by 2, you get pi over 12. So your ending angle right there is pi over 12. You start at 0, and as you map it out, you end up here when you get to pi over 12. So it's important you figure out how to get those angles. So for part 1, it's going to be 1/2 the integral from 0 to pi over 12. My r, which is 4 sine 2 theta minus 2 squared d theta. Now be careful about leaving r squared. This r is general. It's not specific to this function. It just gives you a bunch of r's. That's like if you had y equals x squared minus 2. That's a general term for y. It's not specifically for this function. So if you leave r, that's not specific. Like if you just put r squared, I don't like that. You could do this, r of theta equals 4 sine 2 theta minus 2. Now, technically you could put r of theta squared here, but leaving r is a little sketchy to me. It's like just putting a y. Y is a variable, not a function. Okay? So just got to be careful with that. So that's it for part 1. Now all of this work here could be done on a calculator. You could graph this in, like I said, function mode, and you can see that this is produced from 0 to pi over 12 from your graphing calculator. So you can do that way to make your life easier. All right? So now we need the area of t. So what happened so far, we went from 0 here and ended up here at pi over 12. Now what happens at pi over 12, r becomes positive, and we start mapping out this section. And again, to realize that your angles or your areas are measured through angles. So we started here at theta was pi over 12, and at the end, we ended up back here again. We got to figure out that angle. So what's r at that point? Again, you have r is 0. So let's go back to this. R is 0. And you get to this statement, and you take the antiderivative of pi over 2, or an antiderivative, anti-inverse sine. Well, there's a bunch of angles that have a sine of pi over 2. The first one being pi over 6. But if you continue, 5 pi over 6, and then 13 pi over 6, and it goes on and on. But our theta goes from 0 to pi, so there's going to be a limited number of thetas that you can use. So if I divide 5 pi over 6 by 2, I'm going to get 5 pi over 12. That's going to be my next angle. So this is produced starting at pi over 12, and as I go through the angles, it gets back to 0 at 5 pi over 12. So that's going to be my second integral. It's 1/2 from a to b, r of theta squared d theta. But what's my a to b? I'm going to put it right away. My a to b is going to be pi over 12 to 5 pi over 12. And that's my answer to number 2. Now again, all of this stuff can be done on your calculator in function mode, just finding the x-intercepts. These are the x-intercepts of the r function. That's when your r is 0. So you can do that much more easily just using your calculator. Okay, so 3a. You want to know where the x-coordinate is 1. Well, x is r, more specifically r of theta, cos theta. And you want to know that equals 1. Well, you would do this in your calculator. Put this function in your calculator, graph 1, find where they intersect. And that occurs at, and in this case, comes out to be 2 places. I'll say at a equal 444,913,567. I would store that in my calculator as a. And b, 0.96284,384. You could round or truncate this. You need at least 3. If you do less than 3, you lose your point. So I store that because I know in the future I'm going to be using that. Okay, so that's the answer to 3a. 3b, find the slope. So again, it's important that you tell the grader how you do what you do. So dy dx at theta equals a will be dy d theta at theta equals a over dx d theta at theta equals a. Well, here's the problem. I can do this on my calculator, except I'm allowed to take the derivatives on my calculator. I can do dx d theta, but dy d theta, I don't even know what y is. you need to tell the grader how you find y. So at some point you need to say y is r sine theta. Now I'm allowed to pop that in my calculator. Okay? So at A, the first point, 0.44491 blah, 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 it comes out to be about 0.778. And that's rounded off or truncated. Now, I need the other point, point B. So I'm going to do the same thing. dy dx at theta equal b, which is dy d theta at theta equals b over dx d theta at theta equals b. So again, you're telling the grader how you got the value or your answers. Again, your calculator, you're allowed to take derivatives. So I have my x, I have my y, so I'm allowed to find the derivatives. If you do this, it comes out to be about 0.423 or 4, depending if you round or truncate. And that's the answer for the slope of the line tangent. Next question. Is it moving right or left? This question should have said at these points, at this or these points, depending on how many points there were in part A. But there were 2 points, not 1, so it should have been at these points. But in part A, I didn't tell you whether there was how many points there were. Find the angle or angles, there ended up to being 2. So I should have said point or points. And you want to know if it's moving left or right. What tells you moving left or right? The velocity in the x or y direction. So I need to find dx d theta, which is dx dt, because theta and t are the same thing, at theta equals a, and that comes out to be 4.069, and I do the same thing with the y. And that comes out to be negative 3.025. So at time A, it's moving right. The object is moving to the right. And you have to give a justification and why. Because dx dt at theta equals a is positive. Now I'm not going to write this next one out, but it's moving to the left at this point because the dy dt is negative. All right, number 4. This is the last one. I want to find dr dt. But I have d theta dt, and I have r, an r function. Okay, now we know that theta and t are the same thing. Theta and t are the same, so dr dt, well actually we don't know that. That was for problem 3. We can get dr d theta, and we're given d theta dt. You can see in a chain rule that's going to give us dr dt. So now we're almost done here. We want that at theta equals pi over 2, which equals dr d theta at theta equals pi over 2. Now that you just put in your calculator. You're allowed to take derivatives in your calculator. And d theta dt, you're told, is 3. If you pop that in your calculator, you get negative 24. And that's your dr dt. Now, this is where you have to be careful. Because your derivative of r is negative, it does mean it's decreasing, but it doesn't mean you're getting closer to the origin. And here's why. You need to find your r at pi over 2. And if you put that in your calculator, you end up with negative 2. So at pi over 2, your r is negative, and it's decreasing. So it's becoming a bigger negative number, negative 2, negative 3, negative 4, negative 5. And so it's actually moving away from the origin. So your answer is the object is moving away from the origin. And why? Because there's two reasons. Your dr dt at theta is pi over 2 is negative, and r at pi over 2 is negative. That's your justification. And that's it for this problem.